Hey everybody, gonna try to do two of the friction problems in the same screencast. We'll see how that goes. Um, so, this is friction review problem number one. We are asked to draw a free body diagram and determine three different things: the normal force, the kinetic friction force, and the kinetic friction coefficient for um, a 98 Newton block that is being pulled up and to the right with a certain force. And also to the left with a different force. And we know that it's accelerating. So I'm going to try to figure all that out. We have to find FN, FFK, and our kinetic friction coefficient. All right, so how do we go about this? Well, we start with a block. Excuse me. It has a force of gravity of 98 newtons. And we know that there is a couple forces. There's an applied force, 30 newtons. FAPP equals 30 newtons. We have one up and to the right, where this angle is 30 degrees, of 18 newtons. And we will have a normal force that we'll have to figure out in a second. So, how do we do that? Well, we've got to break our angle into pieces. Excuse me. Break our angle into pieces. So our this is a spring force, so that's an Fs. So this will be our Fsy and our Fsx. So our Fsy is our Fs, which is our 18, times the sine of 30 degrees. And our Fsx, break it apart, is 18 cosine 30. 18 sine 30 is 9, and 18 cosine 30 is 15.59. So 9 newtons and 15.59 newtons. All right, so redrawing our free body diagram, we have Fg, that's our only force down, 98 newtons. We have an applied force, FAPP, to the left of 30 newtons. We have an Fsx of 15.59 newtons, an Fsy of 9 newtons, a normal force of unknown as of right now, and we also have FFK, because we know this thing's accelerating. That tells us that it's kinetic friction. The reason I know it's acting to the right is because twofold. One, it's accelerating to the left, so that tells us that the motion's to the left, which means our kinetic friction has to be opposite that, to the right, but also just because the applied force is greater than the horizontal spring force. This object wants to move to the left, so friction is going to oppose that, make it move to the right. All right, so we got to figure out what our normal force is, and to find that, we know that all of our vertical forces, which is total up minus total down, has to equal 0. So we have Fsy plus normal force minus Fg has to equal 0. Fsy is 9 plus our normal force minus 98 equals 0. Do that real quick in my head. I get a normal force of 89 newtons. All right, so there's my normal force. That part is done. My FFK, a little bit more tricky. I've got to use my net force. My go-to equation, F net equals m times a. But my net force is all of my right forces minus all of my left. And all of my right forces, FFK, plus 15.59, minus my left, which is 30. And that equals my mass times my acceleration. Well, I know those. My mass, I don't really know. I can figure it out, though, because I know that my weight, just do that right here, my weight is 98. Mass is weight over 9.8. 98 over 9.8 gives me 10 kilograms. So my mass is 10 kilograms, and my acceleration is negative 0.04 meters per second squared. That negative because it's left. All right, so I can simplify this a little bit. FFK 15.59 minus 30, negative 14.41 minus 14.41 equals negative 0.4. Add the 14.41, I get an FFK of 14.81. Comes out positive because it's going to the right. And there's our FFK. So we've done that. Last piece we have to find is our mu k. To find that, we look at the force of friction equation. Oops, I'm probably getting into my screen. Excuse me, I'll write over here. Sorry, guys. My FFK, what I got was 14.81 newtons. So that's part B. Sorry about that. That's that number. My mu k, I'll write it up here. Mu k I can find because I know that mu times the normal force equals my force of friction, my FFK. So my FFK I just found. It's 14.81 equals mu k, what I'm trying to find, times my normal force, but my normal force I found. It's 89, which gives me a mu k equal to 14.81 over 89, which is 0.17 or 0.166, doesn't really matter. All right, 0.166. No units because coefficients don't have any units. All right, and there we go. So we broke it apart, found our normal force using all the vertical forces equal 0, found our normal, found our force of friction, used our force of friction to find our coefficient. On the quiz, if I do this type of problem, I may switch it so that instead of the angle being up, it might be an angle going down. The only thing that changes is instead of subtracting the normal force, you would add it. Instead of this being positive, it would be negative. Your normal force would be bigger. But overall, I think that's something still very well within your hands to do. All right, so hopefully that's it, but I'm going to continue on to number 2, friction problem review number 2. So, review problem number 2 is the following. It's a ramp problem. So ramp problems tell us certain information, and we have to find the applied force, what it has to be, and the acceleration. So all ramp problems start with the drawing of the ramp. We have 23 kilogram block, so that means it has some amount of weight. That weight we've got to determine by doing 23 times 9.8 of 225.4. As with all ramp problems, you got to break it apart into its pieces. It's vertical and it's horizontal. This one's FGX. This one FGY. Alright, so we have a 41-degree ramp. Our FGX is always for a ramp equal to our FG times the sine of the angle, and FGY, similar, is FG cosine of the angle. FG 225.4 times the sine of 41 equals 147.88 newtons. And while I was at it, I did the FGY, 170.11 newtons. Alright, so I'm done with the FG. I've used it. My FGY is perfectly canceled with my normal force. So I know that my normal force, right way up here, is also 170.11 newtons. I know that I have a couple forces. I have a friction force that is going to be acting backwards because this block wants to slide downward due to my FGX. But I also have an additional force pulling the block down the ramp. So I have an extra secondary FAPP that I have to deal with. What is the applied force that must begin, that's a key word, the block moving? What I mean by that is right now I'm in static friction. I haven't had it moving yet. So we have to figure out what that FFS is. Coefficient of static friction being 0.91, so mu s times the normal force. 0.91 times the normal force, 170.11, gives me 154.8. I kept all the decimals after 170, so it might be a little low. Might be a little different than your number, but that's not a problem. I got 154.80 newtons. So I have a force apply, a static friction force of 154 going up the ramp. Let me start redrawing my free body diagram. Rotating everything back so that it's perfectly flat. Fg, Fgy, and the normal force cancel out. The force acting up the ramp is my FFS of 154.80. That is the amount of force we have to overcome to the left to get this thing moving. Gravity's helping a little bit. It's helping with 147.88. So it's helping with 147.88 newtons. That's my FGX. But I also have to apply a force to get it moving. To get it moving, obviously I need to have an unbalanced force. So that would say that my applied force, they have to balance each other. My applied force, let me start over. All my right forces, which is just my 154.80, minus all of my left forces, FAPP, plus 147.88, has to be just greater than 0. I have to perfectly match it, or at least be a little bit above it. So solving for that, I do 154.80 minus 147.88, and I get 6.92 as my applied force. So my applied force has to be greater than or equal to, right? That's sort of the breaking point of 6.92 newtons. Okay. Going along with that, almost done. We have to determine the acceleration of the block if the coefficient of kinetic friction is 0.32. So I'm going to erase this. I know that my FGX was 147.88. So once it's moving, the applied force goes away. I only have one force now acting down the ramp. That's my FGX. My FGX. I still have FG, Y, and the normal force canceling out. Don't have to worry about those. And I have one force acting backwards, but because this thing's moving, it's no longer FFS, it's FFK. So I got to figure out what FFK is, my force of kinetic friction. To do that, it's 0.32, which is mu k, times, again, the normal force. The normal force, 170.11, which equals 54.44 newtons. So, to figure that out, I have to set up Fnet equals m times a, which equals my total rate, 54.44, minus 147.88. My net force is 93.44 newtons to the left, or negative, and I will pick up with this on the next screencast because I'm out of time on this one.